All right, so moving on to chapter 21, the beginning section, which you should all excel at, is naming. Why should you excel at it? Because aldehyde naming, specifically aldehyde naming, is going to be very much your view, because aldehyde naming is just like carboxylic acid. Carboxylic acid naming with a new suffix. So if you know how to name carboxylic acids, literally all you have to do is do it the exact same way as that, and then just end with a different suffix. So there are acyclic aldehydes and there are cyclic aldehydes, and just like we name them differently as carboxylic acids, we're also going to name them differently with aldehydes. So acyclic, the suffix functional group component is changed to Al. So aldehyde, like aldehyde. Al is what the end is going to be. And the CHO position, so what is a CHO? Well, CHO is neutral, so you have to combine it in such a way to make those three atoms neutral. The only way to do so is to have it be an aldehyde. So the aldehyde position, so this carbon here of the CHO, that carbon there, is always position number 1. So that is for acyclic aldehydes. So these are 2 acyclic aldehydes. Before we get on to cyclic, let's just name these. So this first one is very simple. This is going to be position 1, 2, 3, and 4. So you might want to pause it for a second, unpause, and do your best to name this. You should be able to do it. Okay, so you've unpaused. So at the 3 position, we have a methyl group. So this is 3-methyl, and then it's bute, because there are 4 carbons. So bute. There are no alkenes or alkynes, so AN, butane, and then it's an aldehyde, so we end with AL. 3-methyl-butanal. One thing that many of you probably did when you paused to try it yourself is you may have said 3-methyl-butan-1-al. There's no need to waste your pen to write -1-al, because the CHO position is always position 1, so we didn't need to do that. So one thing that's going to be changing this chapter to get you in the right headspace for the ACS exam is, in naming questions, I'm now going to be adding stereochemistry. There are 2 stereocenters in this molecule, and they're going to have to be included in the name of this molecule. But first, let's just name it without the stereochemistry, and then we'll add the stereochemistry in at the end. So go ahead and pause it for a minute and try this one. And first, on the first pause, just number it. So pause. All right, now we're going to number it. So this has to be position 1, and then we are going to number to get the longest chain of carbon. So 1, 2, 3, 4, 5, 6, 7. And we could go down there, and then this is an isopropyl group, but we want the longest chain, so this would be 8, and this would be 9. So our longest chain is 9 carbons long, so that's going to be known, N-O-N, for 9 carbons. Really, we can already put the end of it all. It's going to be known. It's going to be known. N-O-N. There are no alkenes, no alkynes, so known, and then the end is the suffix, which goes with the functional group, so that's an aldehyde. Known, al. So now is the part where we need to add stuff for the substituents. So what substituents do we have? At position 2, we have a 1, 2, 3 carbon unit. That's a propyl. And then at positions 7 and 8, we have methyl groups. So alphabetically, M comes before P, so we would do the methyls first. So it's going to be something like 7 comma 8 dimethyl, and then 2 propyl nonanal. So that gets kind of the basic naming out of the way. But now we're going to name the stereocenters. We have to know if it's R or S. So to check yourself at this point, I would recommend you pause the video and see, are you capable right now of naming the stereocenters? Because hopefully you are, but if not, then we'll do it together. So pause, boop. All right, unpaused. Okay, so we have two stereocenters here. The 2 position is the stereocenter and the 7 position is the stereocenter. So what do? We number the substituents on those positions. So this would be substituent 1. Why is it substituent 1? Well, an oxygen is larger than the carbons. According to the rules, larger substituents get lower numbers, so that's why that one's number 1. These two are identical, 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 but then this carbon is higher molecular weight than all of those hydrogens that are attached to that, so this is going to get position 2. This is position 3, and then the hydrogen that's implied there is the 4th priority substituent. So it's set up really well. The hydrogen's in the back, so now we just go 1 to 2, 2 to 3, and we say, is this clockwise or counterclockwise? This is counterclockwise, so we have a 2s for the stereocenter. Counterclockwise is S, it's sinister. It's the sinister way the clocks would work. Backwards. Oh, crazy. Okay. That was weird. Okay, so what about position 7? So position 7, we have to, again, number our substituents. So this one people have a lot of problems with, so I'm going to kind of list them. So I'm going to write this other hydrogen in here. To make it simple, we're going to write groups here. And first we're going to write the hydrogen. That is going to be 4. Then we have this methyl versus a carbon versus a carbon. A CH3 is going to be the lowest option of those, so that's going to be 3. So we have 3 here. We have 4 on that hydrogen. But what about the other 2? So the other 2, let's start, we'll just do A and B. So this is A, this is B. So A, we have a carbon with 2 hydrogens bonded to another carbon. So that's A. B, we have a carbon bonded to a carbon, and it's also bonded to another carbon and another hydrogen. So essentially what the problem that I see a lot of people have with this is they see all this stuff and they're like, oh, A is definitely priority 1. But the only thing that matters is the first point of differentiation. So having 1 carbon and 2 hydrogens on that carbon is a lower priority than having 2 carbons and a hydrogen. So it turns out that B actually gets priority 1 and A gets priority 2. So that is an issue I see various people have with this RS, especially since we haven't covered RS this semester really. So I wanted to make sure we went through that kind of in depth. So at this point we trace 1 to 2, 2 to 3. That is clockwise. So if it's clockwise, it's R. So as far as the stereochemistry on this, it's going to be 2S, 7R, 7,8-dimethyl 2-propyl nonanal. So that is how we name that one. So hopefully the stereochemistry went well for you. If not, maybe you could always obviously go back to the stereochemistry chapter, that's chapter 5, and do some practice problems there. But also feel free to talk to me about things. So that is acyclic. So now we're going to do a cyclic example. So the one on the first page of your notes looks like this. And we haven't really filled in our cyclic system yet. As far as carboxylic acids, we would name, if this was a carboxylic acid instead of an aldehyde, we would name this as a cycloalkane with this is position 1, and we would just end with carboxylic acid. We do the same thing with this, except for we end with carbaldehyde. Carbaldehyde. That's how we end. So the aldehyde is position 1. Then we number around the ring to give the lowest numbers to the next substituent. So 1, 2, 3, 4, 5, 6. So we have a 2-ethyl. So this is going to be 2-ethyl. Ethyl. 2-ethyl cyclohexane. Carbaldehyde. Again, we didn't put a 1 here because it's assumed that if it is a carbaldehyde, if it's an aldehyde on this cyclohexane, that is going to be position 1 no matter what. So no need to say 1 carbaldehyde. Here we again have stereochemistry. So you probably want to pause for a second. Make sure you can do the stereochemistry with this one as well. So paused, unpaused, great. Okay, so in this position here, this is going to be priority 1, priority 2, and priority 3. And that's for this green carbon here. So for this green carbon, 1 to 2, 2 to 3, this is clockwise. So this position here is R. What about this position 2? This is going to be priority, so for the red carbon, this is priority 1, this is priority 2, this is priority 3. So we got 1 to 2, 2 to 3. That's counterclockwise. So this is going to be S. So we would add to the start of this name 1R, 2S, and then the rest of the name. So hopefully that made sense. Let me know if it didn't, and we will talk soon.